The next question we have here, is given that f of s equals, we have the definition of f of x, we have the definition of g of s. They said show that the composition of f and g inverse equals g inverse compose f inverse. What is composition of function? Housing of function. When you put a function inside another function, that's what it is. Composition of function. Are we together here now? And then what do we need? We need to do about the inverse and not inverse thing. Now, all you need to do, the first thing, let's do f compose g. We are going by the LHS first. Judging by the LHS. So first thing you need to do, just put, are we together here now? Just put g of x. We want to try this part first. F compose g. And that is what? F into g of x. So you put g of x, the whole of the function g of s instead of x. You know we have f of x equals to something. Now, but instead of f of x, now we have f of g of x. It means that anywhere you see x, put g of x there. That's what that's the meaning of that word. Anywhere you see x, put g of x. And by that, what do we do? What is our g of x? X over x minus 1. So you substitute, instead of x, you put x over x minus 1. Are we together here? But don't forget, it has got its beautiful definition before this whole thing. So now let's continue. Now the next thing we will continue. Now we already know f of s. Let me run it this way, don't mind me. We already know f of s, what we have there. So now we already know f compose g of s. Like, not, we are not done with it, but we've done it to a point, right? We've substituted g of s for x. So now we now go back to the definition of f of s. We go back to the definition of f of s. And what is the definition of f of s? We said that f of s is what? X minus 1 all over x. So whenever you see x in f of s, you substitute the whole of g of s into it. So instead of x minus 1 over x now, it will now be, what is g of s? That will be x over x minus 1 minus 1, all in bracket, divided by x over x minus 1. Are you getting what I'm saying? That's what we have right here. This is what we have here. And let me continue. Now with this is what we have here. We substitute, instead also we have it this way, x over x minus 1, x over x minus 1. Yes, this is what we have here. X over x minus 1 minus 1, then all divided by x over x minus 1. And you know we can change that to multiplication. But let's deal with the denominator first. Let's make it a common denominator. Like you take the LCM, that was what I did here. Making it a common denominator now. So we definitely have something like x, this is x over x minus 1, then a minus 1. So when you run the fraction, that will be making it a common denominator. Then this one to return to x minus 1. Are we here? At the end of the day, at that part we are left with what? X, open the bracket, minus s plus 1. So at the end of the day, x minus s is 0. So that side you have 1 over x minus 1. Are we together here now? Don't forget, but we still have something. We say it is divided by x over x minus 1. X. So we have 1 over x. That's the in of this side. That's what we've done. So now divided by what? X divided by x over x minus 1. You know how we do this? To change the idea, bring this one up, bring this one down to turn to multiplication, and this one is minus 1 here. So at the end of the day, this one that you took up is going to divide this. So at the end of the day, we are left with 1 over x. So that's how we get 1 over s for that particular part. It means that f compose g, all of x is 1 over s. But what did they want us to find? They now said, okay, let's go for their inverse. The inverse. How do we do the inverse of that? We do that just now. Now what we got for f compose g? What we get for f compose g is actually 1 over x. To get the inverse, set this whole thing equal to y. So y equals 1 over x. Then make s subject of formula. For you to get x subject of formula, cross multiply xy equals 1. Now to make x, the variable side by what? By y. So dividing it by y, then our x equals 1 over y. So that is the inverse of the composition. Now we need to show the left hand side. We want to show is f inverse compose g inverse. Sorry, g inverse compose f inverse. Sorry, g inverse compose f inverse. And from the question, I guess we need to pick what our g inverse is. That is it. I believe you are seeing it. Our f of s is s minus 1 over s. Our g of s is s over s minus 1. So let me continue with this. Our g of x is x over x minus 1, and our f of x is x minus 1 over x. I believe I guessed right, or I picked the right thing. I guess I picked the right thing. So what do we need to do? Let's find the inverse of the two, and then let's run their composition. And to get the inverse, listen again attentively. Just say this one equal to y, then make a subject to formula. Easy. So that's going to be what? X minus 1 over x. Cross multiply it. So that will be yx equals x minus 1. I need to make x the subject. So bring this minus 1 to this side and bring this one to this side. So that will be 1 equals x minus yx. So from there you get 1 equals, factor out the x. That will be 1 minus y. At the end of the day, dividing both sides, x here equals 1 over 1 minus y. And that is the inverse of f, which is what? 1 over 1 minus y. Now let's go for the inverse of g. Now g is of x is defined by what? I guess that is x over x minus 1. X over x minus 1. Once again, what's the gospel? The gospel is change this whole thing to y and make a subject of formula. So that will be equals x over x minus 1. Cross multiply it. When you cross multiply, x equals y into x minus 1. So x equals yx minus y. Once again, you need to make s subject. So bring this y to this side and bring this s to this side. Y is negative here to the positive here, and s is positive here to the negative here. Yx minus x. So the next thing, y equals, what's common to this? X into y minus 1. So dividing both sides by y minus 1, x equals y over y minus 1. And that is the inverse of g. The inverse of g is y over y minus 1. So let's run the composition. G inverse compose f inverse. So that will be g inverse housing the whole of f inverse. What do we get for f inverse? 1. That's 1 over 1 minus y. But g inverse is actually having a definition y over y minus 1. It means anywhere you find, that's the definition of g inverse. Now this is g inverse of, and this is g inverse of x. So anywhere you see s, put the whole of this in. Sorry, g inverse of y. So anywhere you see y, put the whole of this beautiful thing. Are you here? Comparing this g inverse of something to this g inverse of something, if these two cancel out, then y must be equal to this. It means anywhere I see y in this function, I will have to put the whole of this there. So doing that, that will be 1 over 1 minus y. Numerator, simple. Now the denominator now, that will be still 1 over 1 minus y. Then there's a minus 1 here. So simplifying that, that will be 1 over 1 minus y. Keep it equals, make this over 1 LCM, 1 minus y. 1 minus y in 1 minus y is 1. That will be 1 minus, into brackets, 1 in 1 minus y is 1 minus y. Then open it, 1 minus y. So that will be 1 over 1 minus y. Close it up in kind of a way. And then the LCM, 1 minus y. And then that will be just opening the brackets, 1 minus 1 plus y. Someone is saying, how do we get plus? Minus here, and there is a minus here. So minus times minus plus, minus times plus minus. So with that, we are left with 1 over 1 minus y 1 minus 1 is what? 0 times y over 1 minus y. That will be 1 over 1 minus y equals 1. Sorry, mistake. Thank you. Times, to change division to, sorry, it's already in multiplication already. What am I thinking? Oh, where do I even get the multiplication from? I'm coming. Oh, I'm sorry. There's a division in between them. This is divided by, so it will still maintain its definition. There's a division in between them. You know what I'm saying? This is the numerator, divided by the denominator. So there's a divided by there. This is still division. So the division will now change to what? It is still division around here. Still division around here. So the division will now change to multiplication, and then you have what? And then you have 1 minus y over y. This cancels this. We have 1 over y. It means that now when we did G inverse compose F inverse, we still get what? We get 1 over y. And when we did the first side too, don't forget the first part, this one's too, it gave us our composition. The inverse we got here is still what? 1 over y. It means the statement is correct that f of g all inverse equals g inverse g inverse of f inverse. So the statement is correct.